Okay, hello everyone. Today we're going to keep talking about graphing rational functions. So as you guys saw last time, rational functions are actually pretty complicated to graph. Okay, there's going to be vertical asymptotes, there's going to be horizontal asymptotes. Okay, and the reason really that we're doing this is that many of these things, like graphing asymptotes, you will see next year if you're taking pre-calculus, which I think most of you are. So it's okay if you're not completely understanding, what we're going over right now. But my goal is to just kind of get you exposed to these ideas, so that comes next year, these concepts are not completely, brand new to you. Okay, so with that being said, we don't have too many more days left, as I'm sure you've noticed. So once again, it's okay if you're not getting this completely, but again, the goal is to kind of get you guys exposed to this, to get some practice, so that come next year, you can have a better start. Okay, so that being said, let's go ahead and keep graphing rational functions. So last time, everything we graphed was of the form, let's say, y is equal to, let's say, 2 over x plus 3, minus 4. And then this will make a table, and then we'll use x and y, and then we'll use -2, -1, 1, 2, and so on. Vertical stretch by 2, left 3, and down 4. So all this was what we did last time, and again, we have to graph the asymptotes. But in most cases, with rational functions, what the equation is going to be given to you is not going to be in this form. Okay, so if it is in this form, then we do know how to graph it, right? We can just make a table. But the question becomes, what if the equation is not in that form? So that's what we're going to talk about this lesson and the next as well. So let's see. So let's say we're given any rational function of this form. So I have y is equal to, and then I have some numerator over denominator, right? These are what we saw as rational functions. Rational functions is a ratio of two polynomials. Okay, so the numerator could be, let's say, x plus 3, and the denominator could be, let's say, x squared minus 16 or something. Okay, so we'll talk about how we can graph these and find the key features if it's in this form, okay, and not in the form that we talked about last time. All right, so let's go and take a look. And then, so this table I have at the beginning is going to be actually really important. So do make sure you're copying down the notes as I go over these, and I will fill these in as we do the examples. Okay, so let's say I have this equation right here, y is equal to 2x over x plus 3. Okay, so this looks slightly different from the ones we saw last time because we have the variable in both the numerator and the denominator. Okay, whereas last time we only saw them in the denominator. Okay, so let's go ahead and try to find some of these key features. Let's start with one that we all know, and that's y-intercept. Okay, so in general, how do we find the y-intercept for any function? Not just rational functions, but for any function. Okay, and the answer is you will set x equal to 0, right? That's always how we find the y-intercept, is we make x equal to 0. So let's go and do that first. So then I have y is equal to 2 times 0, 2 times 0 over 0 plus 3. So that's going to be 0 over 3, which is 0. Okay, so then my y-intercept is 0. So let me go ahead and put that in. I have 0, comma 0. So that's my y-intercept. And then let's go and graph that as well. So here's 0, comma 0. And then let's also go to x-intercept. We've also worked with these a lot as well. So for x-intercept, let's go down here. So then for y-intercept, we make x equal to 0. So then for x-intercept, we make y equal to 0. Again, hopefully this part is not new for you guys just yet. So let's go ahead and do that. We have 0 is equal to 2x over x plus 3. Okay, so now this is a bit complicated. How do we solve for x? Well, let's take a look. So if I have a fraction, right, this is 2x over x plus 3, that's a fraction, and I want this whole value to be equal to 0, when would that happen? Well, the answer is, if I want this whole fraction to be 0, then my numerator must be equal to 0, right? Because if I have a 0 on top, if I have a 0 on top, then 0 divided by any number, it doesn't matter what my denominator is, right? Because 0 divided by any number is 0, which is what we want. Okay, so the answer is I want to set the numerator equal to 0 to find my x-intercept. Okay, so that's actually one of the key features up here. So x-intercept, let me write that down. To find the x-intercept for rational functions, that is, right, like as we just talked about, you want to set the numerator equal to 0. Okay, set numerator equal to 0, then solve for x. Okay, and then of course for y-intercept, we talked about that as well. You want to set x equal to 0. Okay, so let's go ahead and do the x-intercept. So I'm going to set the numerator equal to 0 and then solve for x. So in this case, the numerator is 2x. So I'm going to set this equal to 0. 2x equals 0. Divided by 2, I get x equals 0. So my x-intercept is also at 0. And that's going to be 0, 0, which makes sense, right? So because that's the same point, right, at the origin. But sometimes there may be more x-intercepts. There may be 2 x-intercepts or, even more than that, as we'll talk about. Okay, so that's for the intercepts, x and y-intercept. And now let's go ahead and move on to the asymptotes as well. As we saw last time, rational functions will sometimes have more than one asymptote, right? As was the case last time, and as will be the case here as well. And let's start by going over the vertical asymptote first. Okay, so for the vertical asymptote, let me go up here. What you want to do is, it's actually the opposite of the x-intercept. So here you actually want to set denominator equal to 0, then solve for x. Okay, so really big distinction here. So for vertical asymptote, it's denominator. For x-intercept, it's the numerator. So let's go ahead and go down to our example. So let's say I want to find the vertical asymptote, VA. Denominator here, in this case, it's x plus 3. So then I want to set x plus 3 equal to 0. And then how do I solve for x? Well, in this case, subtract 3 on both sides, so get x equals -3. Okay, and then this part is actually pretty similar to what we did last time, right? So like, for example, last time, if we had something like y is equal to, let's say, 2 over x plus 6, right? In this case, how would you find my vertical asymptote? Well, this plus 6 tells us that I'm shifting to the left 6. So then instead of my vertical asymptote being x equals 0, it will be to the left 6. So then that will be x equals -6, right? And that's really what we're doing here, is we're setting it equal to 0 and then solving for x. So again, -6. Okay, so this part is kind of similar to what we did last time. So here I get x equals -3. Let's graph that. And again, let's use a different color. X equals -3. There's my vertical asymptote. Okay, and then let's also go to the horizontal asymptote. And this is actually going to be the most complicated one out of all of these. So I will tell you how you can find it first, and then I'm going to do some examples with these. Okay, so for the horizontal asymptote, what you want to do is you want to compare the degrees. Okay, so compare degrees. Okay, and again, the degree, if you forgot, the degree is the highest exponent of your polynomial. Okay, and we'll do some examples, so I think that will be more clear when we do it then. So compare degrees. So if the degree of the numerator is bigger than degree of denominator, okay, so if the degree of the top, the numerator, is bigger than the degree of the denominator, then there is no horizontal asymptote. Okay, so that's the first case. If the degree of the numerator is bigger than the denominator, then there's no horizontal asymptote. Okay, if the degree of numerator is less than the degree of the denominator, I'll just say denominator, then there is a horizontal asymptote, and it's always going to be at y equals 0. Okay, so if the degree of your top is bigger, it's no horizontal asymptote. If the degree of the bottom is bigger, then it's y equals 0. So then the last case, if degree is the same, then my horizontal asymptote, it'll be y is equal to your leading coefficient of the top divided by the leading coefficient of the bottom. Okay, so again, I know these words we've seen before, but you may have forgotten what they mean. But I promise you, once we do some examples, it will be much more clear. Okay, so again, if the degree of the top is bigger, there's no horizontal asymptote. If the bottom is bigger, it's at y equals 0. If they're the same, then it's going to be your leading coefficient divided by the leading coefficient. So the ratio of the leading coefficients. Okay, so let's go ahead and take a look at the example that we were just doing. So for the horizontal asymptote, let's do it over here, horizontal asymptote. Let's look at the degrees. Okay, the degree again is the highest exponent that you see. So the degree of the numerator is 1, right? Because that's x to the first power. The degree of the denominator is also 1. Okay, so they're the same. What happens if they're the same? Let's go back up here. That's the third case. If the degree is the same, it will be y is equal to the leading coefficient over the leading coefficient. So it will be y is equal to, the leading coefficient is going to be the coefficient of the term with the largest degree. So in this case, the leading coefficient here is 2 on top, and then the leading coefficient on the bottom is the number right over here, which is a 1. Okay, so in this case, my horizontal asymptote is 2 over 1, which is equal to 2. Okay, so there's my horizontal asymptote, y equals 2. And then let's go ahead and graph that as well. Okay, again, I know this is confusing. Okay, this is difficult with graphing rational functions, especially, if we're not doing it in person. I'm just kind of, I can't answer your questions over a video, of course. But again, the goal is not for you to master this completely, right? Especially not on the first day, but for you to just kind of get some exposure to, to see what's going on with these rational functions. And then hopefully as you do more practice, you'll get better at these. Okay, so that's it. So that's what you want to do with these, is to first find all these key features, your intercepts and your asymptotes, and then it'll be much easier to graph your function from there. Okay, so here I am. I've graphed my asymptotes. I've graphed my intercepts. So now, of course, we need to draw in the rest of the graph, right? And because we have our asymptotes already, it's going to be pretty easy from here, because what you can do is, well, I know my graph has to go towards the asymptote, right? So I know from here my graph must go up here like this, and then my graph must also go down towards my asymptote like so. Okay, so this is, of course, not exactly what the graph looks like, but this is going to be pretty close. Okay, and that's actually good enough for us. We just want to draw an approximate sketch of this. Okay, so that's that. But then there's also going to be a second part, right? There's going to be a part over here as well, but we don't know where that's going to be, right? But what you can actually do is we can actually just pick a test point. Okay, so let's pick a point that's going to be, in this region that's highlighted. So let's pick an x value in that region. Let's say I'll pick x is, I don't know, -5. Okay, so I'll pick x is -5, and I want to find what y is. Well, now I can just plug that into the equation. So y is equal to 2x, so 2 times -5 over -5 plus 3. So that's -10 over -2, which is 5. So when x is -5, y is 5. So let's go ahead and graph that as well. When x is -5, 1, 2, 3, 4, 5, y is 5. So y is all the way up here. And now all I need is just that one point, because now I know that my graph is going to follow my asymptote. So my graph will go down like here towards the asymptote, and then same thing up here, going towards my asymptote. Okay, and that's really all we need. Again, this is not an exact sketch of my graph, but this is pretty close. Okay, and pretty close is good enough in our case. And then lastly, let's go ahead and do domain and range. In this case, just like last time, domain will be all real numbers except some value. In this case, x cannot be -3 because we have an asymptote there. And then similarly, range, y is all real numbers except y cannot be 2 in this case. That's where the asymptote is. okay? All right, let's go ahead and do one more example. Again, doing the same thing that we just did by starting with the key features. Okay, let's always start with the intercepts because I think that's the easiest place to start. So for y-intercept, we set x equal to 0. So we have y is equal to -0 plus 3 over 0 minus 2. So that's 3 over -2, or -1.5. So there's my y-intercept, 0, comma, -1.5. Always write these as points. So that's going to be somewhere over there. X-intercept, let's go back to the notes up top. X-intercept is over here. Set numerator equal to 0, then solve for x. So numerator equal to 0, that's -x plus 3. Set that equal to 0. Solve for x. Well, I'm just going to add the x to both sides. I get x equals 3. And so there it is. Again, let's write that as a point, 3 comma 0. That's right over here. All right, asymptotes now. Let's start with vertical. That's set denominator equal to 0, then solve for x. So denominator, let's go over here, vertical asymptote. Denominator is x minus 2. Set x minus 2 equals 0. I get x equals 2. X equals 2. Let's graph that as well. Again, using a different color, preferably. And then last but not least, horizontal asymptote. Go back up here. What does that say? Compare the degrees. All right, here we go. Compare the degrees. The degree on top is 1. The degree on the bottom is also 1, once again. And if they're the same, what happens? Well, you take the leading coefficient over the leading coefficient. So then we have y is equal to, what's the leading coefficient on top? Well, there's a negative sign there, so that tells us it's -1. And then on the bottom, again, it's just going to be 1. So -1 over 1. -1 over 1 is -1. So we have y is equal to -1. And let's go ahead and graph that as well. So y equals -1. It's going to be right over here. There. Okay, and now let's go ahead and finish the rest of our graph. So let's see, because we have a point right up here, that's our x-intercept. We know my graph will have to go towards the asymptote over here, as well as up here. Okay, simple as that. And then same thing over here. I have a point on this side also, so I'm gonna have to have a point, or I'm gonna have to have the graph going this way towards the asymptote, and then also going down this way towards the asymptote. Okay, so the shapes actually look pretty similar to the ones that we did last time, but the functions are different, right? Because here the functions have the variable on both the numerator and denominator. Domain and range. Domain, all real numbers except x cannot be 2, it looks like. And then range, all real number except y cannot be -1. Okay, so that's the graphing, and then I think there's actually 2 more for you guys to try as well. Again, just do the same thing that I just did. First, by finding the key features using your notes right up here, and then sketch your asymptotes, and then from there, I think it should be easier to join the rest of your graph. And now there is a third page of this as well, and that's just to find the key features. Okay, I think there's 6 of these, and I'll do a couple of these with you guys as well, just to kind of get the hang of this. But again, it's actually the same thing that we just did, except without the graphs. Okay, so let's say we'll do this one right over here. All right, x-intercept. Once again, if we go back up top, you set the numerator equal to 0, solve for x. So let's do that first. X-intercept. Set numerator equal to 0, so that's x squared equals 0. So then that tells us x equals 0. So my x-intercept is 0, 0. Y-intercept, that's always the same thing. You make x equal to 0, and then solve for y. So then y will be 0 squared over 0 plus 6, which is again 0, 0, 0. And then the asymptotes, let's go back up here, go back to our notes. Horizontal asymptote compared to degrees. In this case, the degree of the top, so let me do it down here, horizontal asymptote, the degree of the top is 2. It's a 2 right there. The degree of the bottom is 1. So the degree of the top is bigger. What happens if the degree of the top is bigger? Well, that's the first case. If the degree of numerator is bigger than the denominator, then there is no horizontal asymptote. So that's kind of nice. None. And then how about the vertical asymptote? That's going to be the denominator equal to 0. Okay, so let's go ahead and do that. So this was none. Vertical asymptote, let's set the bottom equal to 0. So that's x plus 6 equals 0. And that tells us x equals negative 6. And there it is. Okay, the domain range should not be here, so I'll make sure that's removed on your worksheet. Again, we don't really know how to find that unless we have the graph in front of us. So this you don't have to worry about. All right, and then let's do one more. Let's do one of these bottom ones that are slightly more complicated. Let's say this one right over here. Okay, so this is x squared minus 36 over x squared minus 9x plus 20. So let's first do the y-intercept. It doesn't really matter which one you do first, but it's always going to be, how you do them is always going to be the same according to our notes. So let's say x equal to 0. So I get y is equal to 0 squared minus 36 over 0 squared minus 9 times 0 plus 20. And then you'll notice I get negative 36 on top and then 20 on the bottom. Okay, so this is going to be a fraction, but you can use a calculator to find what that is. That's going to be negative 1.8. So 0, comma negative 1.8. And then, since we have it in this form, let's look at the horizontal asymptote as well. And again, you want to compare the degrees. So degree on top is 2. On the bottom is also 2. What happens if the degrees are the same? Well, you look at the leading coefficients. So it'll be y is equal to, leading coefficient on top is 1, on the bottom is also 1. So it will be y equals 1. And again, don't worry about the domain range. All right, and then let's do the x-intercept and the vertical asymptote now. So then we need to set the top equal to 0 for the x-intercepts. And I think you'll see what's going to come. We have to first factor it. Okay, so on top, it's going to be x plus 6, x minus 6. On the bottom, it's going to be x minus 4, x minus 5. Right, if we were to set the top equal to 0 or the bottom equal to 0, we have to factor our quadratics first. Okay, so then for the x-intercept, if we set the top equal to 0, what would I get? Let's see. I just use this color. So for x-intercept, if I set x plus 6, x minus 6 equal to 0, what do I get for x? Well, I get x equals negative 6 or 6. And then remember to write these as points, negative 6, comma 0 or 6, comma 0. And then what happens for my vertical asymptote? If I set the bottom equal to 0, well, I'm going to get x equals 4 and x equals 5. So then I get 2 vertical asymptotes. Okay? All right, so that's pretty much it. Once again, I know this is difficult, right? This is pretty complicated, more so than anything we've graphed this entire year, which is why this is actually the last unit of the year. And it's especially difficult because we're not doing it in person, so I can't be there to answer your questions. But once again, the goal is not for you to, or at this point, the goal is not for you to completely master this, given how little time we have left of the school year, and the fact that we're doing it remotely as opposed to in person. But again, it's good for you guys to at least get exposed to this so that you are more prepared for next year. Okay, so as always, make sure you take notes, and please do let me know if you have any questions. I know this is difficult for all of us during this time. And once again, I do really appreciate all the hard work that you're putting in. Many of you are, asking me questions and submitting these assignments and showing all of your work. So I really do appreciate all your hard work. But yeah, other than that, thanks for watching. Please try the assignment, use your notes, and do ask me questions. And I'll see you guys next time.